The differential flow meter is the most common device for measuring fluid flow through pipes. Flow rates and pressure differential of fluids such as gases, vapors, and liquids are explored using the orifice plate flow meter. The differential flow meter, whether Venturi tube, flow nozzle, or orifice plate style, is an inline instrument that is installed between two pipe flanges. The orifice plate of the flow meter is comprised of a circular metal disc with a specific hole diameter that reduces the fluid flow in the pipe. Pressure taps are added on each side of the orifice plate to measure the pressure differential. According to the laws of conservation of energy, the fluid entering the pipe must equal the mass leaving the pipe during the same period of time. The velocity of the fluid leaving the orifice is greater than the velocity of the fluid entering the orifice. Applying Bernoulli's principle, the increased fluid velocity results in a decrease in pressure. As the fluid flow rate increases through the pipe, back pressure on the incoming side increases due to the restriction of flow created by the orifice plate. The pressure of the fluid at the downstream side of the orifice plate is less than the incoming side due to the accelerated flow. With a known differential pressure and velocity of the fluid, the volumetric flow rate can be determined. The flow rate, Q, of a fluid through an orifice plate increases in proportion to the square root of the pressure difference on each side multiplied by the K factor. For example, if the differential pressure increases by 14 psi with a K factor of 1, the flow rate is increased by 3.74.